Hello and welcome to this special holiday deep dive. It is December 24th, 2025. Across the globe, billions are settling in for Christmas Eve parties. The lights are dimming and the year is winding down. But here at the Space Science Desk, the screens are brighter than ever. While the world looks inward to family and tradition, a smart group of astronomers, geophysicists, and data experts are looking outward, locked in a big fight that has only grown in the last 96 hours. We are talking, of course, about the Interstellar Object 3I Atlas, also named as C2025N1. If you thought the story of this visitor ended when it quietly flew past us earlier this week, you would be wrong. In fact, the story is just beginning. Let's look closer at the facts. 5 days ago, on December 19, 2025, 30I Atlas reached its point of closest approach to Earth. It was a moment expected for months, a gravity keyhole that offered us the best look we would ever get at this traveler from another star system. Telescopes from the Atacama Desert to the high peaks of Hawaii were aimed at its path. We expected high-quality light curves. We expected chemical tests of its surface makeup. We expected, frankly, acquired proof of its comet or asteroid nature. What we got instead was a broken agreement and a science group that is currently split down the middle. As we sit here on Christmas Eve, the data coming in isn't solving the puzzle, it is making it deeper. Before we dive into the strange things that have appeared in the last few days, if you like this kind of serious data, first look at Space Science News. Make sure to hit that subscribe button. We track these stories not just when they start, but as they change. And you won't want to miss the news coming in the next few weeks as 3I Atlas heads toward the outer solar system. Now, to understand why this flyby has become so debated, we have to remove the headlines and look at the real timeline. The object's approach was normal. Its orbital movements were, for the most part, following the laws of Kepler and Newton. But as it swung by Earth on the 19th, the quiet watching was broken by a claim that has since moved through the fringe science groups and is now knocking on the doors of regular schools. This wasn't a visual glitch. It wasn't a sudden bright flash or a breaking event, which are common for comets under solar heat. This was something hidden, something that speaks to the basic electric environment of our own planet. The story that has ruled the last few days focuses on a series of clashing reports. On one hand, we have the firm's silent data from radio telescopes earlier in the year, which we will get to, suggesting this object is as dead as a rock. On the other hand, we have new rising data from the moment of closest approach that suggests 3I Atlas might be reacting with Earth's magnetic field in ways we didn't guess. This goes against what we used to think about the quiet nature of small space bodies. Usually, a rock is just a rock. It reflects sunlight. It might let out a little water gas or carbon monoxide, but it doesn't speak. It doesn't send signals. Yet, the reports coming in from private researchers suggest that for a short time during the flyby, the electric silence was broken. We need to be very exact here. When we talk about signals in this way, the public mind immediately jumps to aliens, to talking, to hello. But in science, a signal is simply a change from the noise. It is a pattern where there should be randomness. The fight going on today isn't necessarily about little green men. It's about physics. It's about whether a space object traveling at high speed can cause a ring in the Earth's own atmosphere, or if what we are seeing is a chance of huge size. The timing is the first part we have to separate. The object reached its closest point on December 19th, but the event of interest, the spark, if you will, reportedly happened hours before that exact moment of closest approach. This is a vital detail. If 3I Atlas were sending a steady signal, we would have seen it for weeks. We didn't. If it were a simple bounce of solar radar, it would follow a predictable curved line. It didn't. The glitch was short. It appeared, it peaked, and it left. This short nature is what makes it so hard to prove and so easy to ignore. But it is also what makes it impossible to forget. Imagine the Earth not just as a rock, but as a giant magnetic bell. The atmosphere and the sky layer form a whole, a space where electric waves bounce around. Usually, this bell rings with the messy hits of lightning storms, thousands of them happening every second around the world. This creates a hum, a background noise that we call the Schumann Resonances. It is the heartbeat of the planet's electric path. The claim on the table is that 3i Atlas didn't just fly past the bell, it hit it. Or more strangely, that it hummed in tune with it. As we move through this search, we are going to study the exact pitch of this hum. We are going to look at the exact clock time 02:40 UTC, and we're going to ask why a geologist, not an astronomer, was the one to find it. This is a story about the meeting of two very different areas. The study of the stars and the study of the ground under our feet. It turns out that looking up and looking down might have found the same secret. So what does this actually mean for our knowledge of 3i Atlas? It means that the normal model of this object, a frozen piece of nitrogen or hydrogen ice spinning through the dark, is facing a hard test. We have to match the visual silence with the electric noise. We have to understand how an object could be radio quiet in the high range, as proven by our most strong tools, yet apparently yell in the very low frequency range just as it brushed past our planet. The holiday season is usually a time for quiet thought. But for the scientists studying the huge piles of data from December 19th, there is no quiet. There is only the noise, the signal, and the desperate try to separate the two. As we pull back the layers of this meeting, remember that in science, the most exciting words aren't eureka, but that's funny. And right now, looking at the data from the 19th, there are a lot of people saying, that's funny. This brings us to the exact way of the claim. To understand the glitch, we have to understand the tool that found it. We have to leave the high mountain labs and go down to the ground level to the wire coils and the magnetic tools. We have to talk about Stefan Burns. As we noted in the earlier part, the flyby of 3i Atlas on December 19th was not the quiet, purely visual event many astronomers had guessed. While the light telescopes were following a dim point of light moving against the distant stars, a different kind of listening was happening on the ground. A listening aimed not at the high frequencies of deep space talking, but at the extremely low frequencies, or ELF, that pulse through the Earth's own air. This is where the story moves from the stars to the tools, and specifically to the findings of American geologist Stefan Burns. Let's look closer at the data Burns has shown. While the world was watching the clock for the closest approach, Burns was checking the Earth's electric heartbeat. His claim centers on a specific time mark, Ru-240 UTC, on December 19, 2025. To put this in context, this is about 3 hours and 20 minutes before 3i Atlas reached its absolute closest distance to Earth. In space paths, this is close range. The object was racing through the inner solar system, pulling its gravity and maybe electric power with it. It was in this window Burns says that his tools recorded a clear electric glitch. Now you might be asking, what does a glitch look like on a chart? Usually, when we look at ELF data, we see mess. We see the sharp, random spikes of global lightning strikes. Lightning is a wide sender. It throws energy across a big range of tones like a rock thrown into a pool, creating messy, overlapping waves. But Burns says that what he saw was not a splash, it was a laser beam. He reported a signal that was thin and very focused. It didn't move. It didn't blur out. It sat steady at exactly 25 Hz. Here is the vital detail. 25 Hz is not a random number. It sits right inside the group of the Schumann Resonances. For those who might not be aware, the Schumann Resonances are a set of peak tones in the very low frequency part of the Earth's electric field range. They are global electric rings made and started by lightning hits in the space formed by the Earth's surface and the sky layer. The main frequency is usually listed as 783 Hz, with extra tones at roughly 14, 20, 26, 33, 39, and 45 Hz. So a signal at 25 Hz is right in the area of the third tone. But, and this is a huge but, natural Schumann rings are not sharp lines. They are wide peaks. They breathe. They change with the time of day, with sun activity, with the world heat. A natural ring at 25 Hz should look like a soft hill on a chart. Burns describes his find as a spike, a needle in the haystack. He noted that this signal differed greatly from normal air noise. It lacked the mess of nature. It looked, for lack of a better word, man-made. Or at the very least, it looked like a forced wave, something being pushed by an outside power rather than just ringing on its own. This goes against what we used to think about the link between space objects and Earth. We mostly assume these objects have no charge, or at least not enough to push a current in the Earth's sky layer from a distance. But if 3I Atlas were carrying a large plasma tail, or if it had a strong built-in magnetic field, something rare for small bodies, it is maybe possible it could cause a change. However, a change usually looks like a wave, a twist. It rarely looks like a pure 25 Hz tone. Burns's finding at 024A UTC suggests a lock. It suggests that as the object came near, something clicked on. The signal appeared, held steady, and then likely faded or was lost as the position changed. This behavior is what makes the claim so exciting and so annoying. If it were a steady signal, other stations would have found it. But because it was short, appearing only briefly before max closeness, it exists in that gray area of unproven single-source data. However, we cannot simply ignore it as tool error without looking at the context. Burns is not claiming this was a radio message. He is not claiming he read a greeting. He is pointing to a physical link. He is suggesting that the object acted as a switch. And this is where the story gets even more tricky, because 25 Hz isn't just a tone in the sky. It's a tone that has been whispered about in the ground. Burns didn't just report this as a space weather event. He immediately made a link to the solid Earth. He argued that this tone lies within a range that some experts have before linked to possible earthquake signs. This is a bold jump. It moves the talk from interesting space glitch to possible planet danger. He pointed to a similar electric glitch, a ghost signal that was supposedly found several days before the strong earthquake that hit Japan earlier this month on December 8, 2025. So, what does this actually mean? Are we looking at a chance, a tool error, or are we seeing a link between a space flyby, the sky layer, and the ground plates? The idea seems like science fiction, but the data point at 25 Hz stands there clear and unexplained. It dares us to ask if our watching of these objects has been too small. We have been looking for light. We have been looking for heat. Maybe we should have been listening for the hum. As we move to the next part of this search, we need to strictly check this seismic link. Is there any science to support the idea that a 25 Hz signal can predict a quake? Or is this a case of finding patterns in the noise when none exist? The link to the Japan quake is the most debated part of Burns's idea, and it needs a doubting, hard-nosed look. Building on this find of the 25 Hz glitch, we find ourselves moving into one of the most argued areas in geophysics, the guessing of earthquakes. Stefan Burns didn't just leave the data as a wonder of the sky layer. He tied it to the ground by linking the 25 Hz signal seen during the 3I Atlas flyby to the shaking event in Japan on December 8, 2025. He has started a fight that goes far beyond space study. Let's look closer at the data about this ground link. The earthquake in Japan on December 8th was a big event, a strong shake that reminded the world of the Pacific Rim's danger. In the end, as is common, experts rushed to find signs, warning marks that might have been missed. Burns says that a similar electric glitch ringing in that same low-frequency band came before the break. His point rests on the idea of ground-atmosphere-sky layer coupling. The theory goes that before a big quake, the huge pressure building up in the rock makes tiny cracks. These cracks can release charged gas or make electric currents, which then move up into the air and shake the sky layer. If, and it is a huge if, this process is real, then a spike at 25 Hz could maybe be a scream from the rocks before they snap. Burns is suggesting that the signal found during the flyby of 3I Atlas shares a mark with these Earth warning signs. But here is the vital detail that makes his story hard. The Japan quake happened weeks before the flyby. The signal Burns found on December 19th happened when the object was nearest. Is he suggesting the object caused the quake in the past? No. He is suggesting that the type of signal is the key. He is arguing that 3I Atlas might be an active body, geologically or electrically able to make the same kind of stress signal that a moving ground plate makes. This goes against what we used to think about the distance of these systems. Main science remains very doubting of electric earthquake signs. For decades, scientists have hunted for a sure magic signal, be it gas, animal acts, or radio waves. While there have been interesting single cases, the life of a sure link between shakes, low-frequency electric signals, and space events remains very debated and unproven within the wider science group. The agreement is that while the sky layer can be shaken by quakes after they happen due to sound waves, the idea that the sky layer predicts the quake with a specific 25 Hz tone is not backed by solid repeatable data. So what does this actually mean for the 3i Atlas story? It means we have a matching problem. We have a sample size of 1 flyby and 1 earthquake. Burns is drawing a line between two dots that are far apart in time and space. The doubt from the science group is not just being stubborn, it is a guard against fake patterns. If we accept that 3i Atlas sent a quake-like signal, we have to explain the way. Is the object under pressure? Is it shaking? Or is it causing pressure in the Earth? There is no proof that 3i Atlas started any ground activity on Earth during its flyby. The ground did not shake when the signal appeared at 0240 UTC. This lack of a real quake during the flyby actually makes the direct link weak. If the signal is a warning, where is the event? Unless, of course, the signal was the event, a purely electric link that copied the mark of a quake without the real break. Before we go further, I want to hear from you. Do you think science is too fast to ignore these fringe links? Or is it right to ask for huge proof for such huge claims? Drop a comment below with your take on the Burns idea. Is it a big step or a distraction? This links to the wider problem of seeing what we want. When a strange object enters the solar system, we tend to put our current fears and secrets onto it. In 2025, with sun activity high and ground nerves shaken, it is natural to look at the guest and ask, did you do this? But science asks, we look at the zero guess. The zero guess says the 25 Hz signal was a local noise, a power grid change, a Navy boat talk which often uses ELF, or a tool error that just happened to match the flyby. However, even if we take away the quake theory, the 25 Hz signal remains a data point that refuses to fit the line. It stands in sharp contrast to the other main dataset we have on this object. While Burns was looking at the low tones of the Earth, astronomers had before searched the high tones of the stars, and their results showed a very different view of 3i Atlas. To understand the full puzzle of this object, we have to turn the clock back to July. Long before the Christmas flyby, when 3i Atlas was still a far speck, the big names of radio study took a shot at it. They weren't looking for quake signals, they were looking for tech. And what they found, or rather what they didn't find, creates a cool tension with the new claims. We need to check the high-range silence. Given what we now know about the low-frequency glitches reported during the December flyby, we must turn to the other side of the range. Science is rarely about a single look. It is about the joining of clashing datasets and the claims of a 25 Hz hum stand in clear contrast to results found earlier in 2025 to one of the most full radio studies ever done on a space visitor. Let's look closer at the data from the Allen Telescope Array, ATA. Placed in the cascade of radio-quiet mountains in California, the ATA is a hunter. Its prey is the man-made, the tech, the non-natural. On July 2, 2022, months before 3i Atlas would touch the Earth, astronomers started a focused 25-hour watching task. The object was far, dim, and moving against the star background, but the ATA locked on. The size of this study was huge. They didn't just listen to a single path, they scanned 3i Atlas across a wide tone range from 1 to 9 GHz. This is the microwave window, the waterhole of the space, where the background noise of the galaxy is quietest, and where humans, and likely other minds, would do long-range talking. If 3i Atlas were a probe, a ship, or a piece of active tech, this is where it should have been yelling. The first raw data was too much. The study gave nearly 74 million possible signals. This number sounds huge, but in radio study, possible just means a blip above the line. It includes satellites, cell phones, plane radar, and the heat hiss of the telescope itself. The real work is in the cleaning. Here is the vital detail. The team used big filters made to get rid of Earth radio noise. They looked for signals that moved with the object. If a signal is from Earth, it stays still relative to the ground. If a signal is from 3i Atlas, it must move across the sky, matching the exact space path of the guest. After this strict speed sorting, the 74 million choices vanished. Only 211 signals stayed. 211 won sparks in the dark. Each one was a possible hello. But science is mean. A later eye check of these choices, looking at their wave shape, their timing, their stay, failed to find any sends matching a tick mark. There were no prime number patterns, no thin waves that defied logic, no man-made send worthy of more study. The 211 survivors were tossed out as math errors or small noise. So what does this actually mean? It allowed experts to set a hard top limit on the object's possible send power. They figured that if 3i Atlas was sending, its power was guessed to fall between 10 and 110 watts. Think about that. A normal light bulb, a wide sender on 3i Atlas with the power of a desk lamp would have been found. The silence was very loud. These finds were later talked about openly by Harvard expert Avi Loeb. Known for his bold ideas about Oumuamua, Avi Loeb is not one to hide from man-made answers. Yet in this case, he wrote in his blog that, despite wide guesses, the radio data gathered so far give no proof of man-made acts linked with the space object. When the main fan of Space Ruins says the radio line is dead, it has weight. This creates a deep tension in our story. How do we match the high-range silence of July with the Schumann hum of December? Are they unable to both be true? Not necessarily. The ATA looked for high-frequency talking, the kind used for data move. Burns looked at low-frequency ring, the kind linked with magnetic link or engine side effects. It is possible for an object to be radio quiet in the high range. No Wi-Fi, no data, but electrically active in the ELF range. Magnetic slowing plasma link. However, the easiest answer is often the right one. The ATA data is solid, peer-reviewed, and math-strong. The Burns data is single, short, and tied with debated quake theories. The silence is the base. The hum is the oddity. But the story of 3i Atlas didn't end with a radio silence. It didn't end with a flyby. As the object swung past Earth, it did something that no radio tool could miss and no geologist could ignore. It moved. And it moved in a way that is now setting up the final act of this space play. The object is no longer coming toward us. It is flying away, and its goal is the king of the solar system. As we track 3i Atlas on its way out, we are seeing a speed up. It is gaining speed as it moves away from the sun. This non-gravity speed up is the mark of comets. Jets of gas pushing the rock like engines, but without a seam tail, without the cloud that usually goes with such speed, the way remains hidden, and now the path is taking it toward a meeting that feels almost planned. It is heading toward the area of Jupiter. As we noted, the secret of 3i Atlas is defined by what we don't see as much as what we do. We have the silence in the high range, the debated hum in the low tones, and now as the object fades into the dark, we have the path itself. After its close meeting with Earth, 3i Atlas kept its trip through the solar system. But it is not moving lazily, it is speeding up. Let's look closer at the data on this exit. As 3i Atlas moves away from the sun, it should be slowing down, fighting the gravity pull of our star. Instead, it is showing a small, steady push. In comets, we call this outgassing, ice turning into gas and acting like a rocket motor. But 3i Atlas remains strictly a point. Deep photo shots show no long tail, no fuzzy cloud. It is a dark, small speeder. This dark push keeps the man-made debate alive. If it's not gas, what is pushing it? Sunlight pressure, a magnetic sail, or simply gas that is too dim or clear for our current tools to find? This links to the final goal of our visitor. The figured path is heading toward the area of Jupiter. Current space models suggest it will pass near one of the planet's moons before finally leaving the solar system for good. This Jupiter meeting is a poetic, if random end. Jupiter is the vacuum cleaner of the solar system. Its huge gravity hull usually eating or throwing out comets for 3i Atlas to hit the mark passing Earth and then brushing past the Jovian system offers one last chance for study. Jupiter flyby will be far, But the link with the giant planet's strong radiation belts and magnetic field could be the final stress test if 3I Atlas reacted to Earth's fairly weak magnetic field with a 25 Hz hum. What will it do when it hits the magnetic beast that is Jupiter? Will it light up? Will it change path again? Astronomers are already booking time on the James Webb Space Telescope and the coming ground giants to watch this exit. So what does this actually mean for us? 3I Atlas is once again showing how rare space visitors can test current ideas while still giving more questions than answers. It came, it confused us, and it is leaving. It leaves behind a broken dataset, a clean radio study, a messy low-frequency claim, and a path that defies simple gravity. We are left with a puzzle that may never be fully solved. Was it a piece of a nitrogen iceberg, hidden to radar, but active enough to speed up? Was it a piece of junk from a broken Dyson sphere, silent but electrically charged? Or was it just a rock, and we, in our hope for a link, put our own signals onto it? The beauty of science is that the file is never really closed. The data gathered on December 19th, the ATA scans from July, and the coming Jupiter looks will be studied for decades. College students not yet born will write papers on the Christmas guest of 2025. If you liked this deep dive into the unknown, if you value news that respects your brain and searches the edges of what we know, please hit that like button. It helps this video find other curious minds in the system. And keep your eyes on the skies because the space is full of things that don't knock before coming in.